Welcome. Today we're going over notes 5.4, normal distribution, empirical rule, and z-score. So when you see normal distribution, empirical rule, right, that's the same thing as saying normal distribution. So this is another way to analyze the data. So one special type of distribution is called normal distribution or a normal model. The normal model is often thought of as the bell curve. So down here in the notes, right, these are bell curves. A bell curve happens when the data is unimodal. So it's single peak. It has one high peak. The distribution on each side of the peak is symmetric. When the distribution data is deemed to fit a normal model, the standard deviation is used to break up the normal model into defined sections. The center is labeled as the mean of the data. It has a standardized score of 0 due to the fact that it's 0 standard deviation from the mean. So this would have a standardized score of 0. That's the mean. So if you go to the right and to the left, one standard deviation, that is where 68% of the data falls. So then that means this is 34 and this is 34 because it totals 68% if you're within one standard deviation. And again, this is if we have a normal model. If you're within two standard deviations, so positive 2, negative 2, that's 95% of the data. So this increased by 27%. So if it's symmetric, that means it's split in half. So each would be 13.5. Again, because from 68 to 95 is 27%. It's symmetric. So you have half on one side and half on the other. So that's half of 27 is 13.5. And then if you're within 3 standard deviations of the mean, so negative 3 to 3, that's 99.7%. So that's 4.7% increase. So that means that this would be 2.35, 2.35. So how much is left? Because this is supposed to be 100% of the data. So what's left, right, is 0.3. So then this would be 0.15, 0.15, right? Because half of 0.3 is 0.15. So what's nice about this normal distribution is these are going to be the breakdowns every time. So this is something you're going to want to memorize. So anytime you hear normal model or the empirical rule, right away you should be thinking of this bell curve that's on your screen right now. That's probably what you're going to use to help you solve the problem. So we're going to apply this bell curve to our next example. So traffic studies have shown that vehicle speeds of a certain portion of the freeway follow a normal model. As soon as I hear normal, I'm thinking bell curve. The average speed is 67. The standard deviation is 4 miles per hour. So your mu and your sigma, right? It's normal. Remember, mu means mean, sigma means standard deviation. Right? Again, remember that symbol is mu. Okay, so if our standard deviation is 4, our mean is 67, so this is going to be 67, right here in the middle, because we always put the mean in the middle. So if you're within one standard deviation of the mean, right, this would be, if the standard deviation, this is one standard deviation above the mean, this would be at 71. Why 71? Because the standard deviation is 4. So if you're 1 standard deviation above the mean, you're at 71 miles per hour. If you're at 2 standard deviations above the mean, you'd be at 75. If you're at 3, right, you'd be at 79. If you're 1 standard deviation below the mean, the -1 means below, right, you'd be 4 miles per hour slower, so 63. If you're 2 standard deviations below the mean, so -2, the minus just means below, positive means above, then you'd be at 59. And if you're 3 standard deviations below the mean, you'd be at 55. So the numbers adjusted because in terms of the problem. So our average is 67. So that's why 67 is in the middle. These are increasing by 4 because the standard deviation is 4. Okay, so if you're within 1 standard deviation of the mean, right? Remember, plus or minus 1 standard deviation, that's 68% of the data. So this would be 34 and 34 because it's symmetric. It's split into 2. If you're within 2 standard deviations of the mean, that's where 95% of the data falls. So this is going to be 13.5, 13.5. Why? Because from here to here, that's an increase of 27%. And it's symmetric, so split into 2 evenly. That's where you get the 13.5. And then if you're within 3 standard deviations, right, that's where 99.7% of the data falls. So this would be 2.35, 2.35. Because again, this is increasing by 4.7. So it's symmetric, the bell curve, so you split that in 2. And then what's remaining is 0.15 and 0.15 because there's 0.3 left. Okay, it's supposed to total 100%. So we have 0.3 that's left. So we split that into 2 even parts. That's why it's 0.15 on the right, 0.15 on the left. So again, the only numbers that changed were these numbers right here because that depends on the problem. Right? 67 still 0 standard deviations from the mean because it's the mean. 71, right? 71 miles per hour is 1 standard deviation above the mean because its standard deviation is 4. So what percent of vehicles traveled over 71 miles per hour? So 71 and above. So here's 71 and above. So anything above there is what I'm looking for. So I'm just going to add those percentages up. So I would add 13.5 plus 2.35 plus 0.15. And if you add those together, right, that's 16%. Okay, between 63 and 75. So 63 to 75. So I'm going to add, right, 34 plus 34 plus 13.5. I'm going to add these 3 numbers together because it's between 63 and 75. So add those together and you get 81.5%. So 81.5% of the data, right, is going to fall between 63 miles per hour and 75. Wait, less than 67? So here's 67, so less than 67 would be everything below. So I could add up 1, 2, 3, 4, or realize that 67 is the middle, so 50% of the data is above, but also 50% of the data is below the middle. So this would just be 50%. Right, between 55, So here's 55 and 63. So between 55 and 65. So that would be 2.35 and 13.5. Add those together and you get 15.85%. So again, those numbers underneath the bell curve are the percentages of the data. So again, between 55 and 63, right, 55 to 63, you have 13.5% and 2.35. Add those together to get your 15.85%. More than 63, so 63 and more, so that would be everything to the right of 63. So I could add up, right, 1, 2, 3, 4, 5. Right, I could add up all 5 of those. That would work. Or you can think about, okay, well, from here, from that blue dot on, well, this blue dot down is 50% plus 34, right? So I could just do it the easier way. It's probably just 34 plus 50. So it's 84%. So again, from 67 this way, where that blue line is, that's 50% of the data. Plus, you add this little piece here, right? That 34, that gives you the 84%. Wait, less than 59. So here's 59. Less than that would be everything this way. So that would just be your 2.35 plus your 0.15. So that's 2.5%. Wait, the middle 95% of the vehicles traveled between what two speeds? So 95%, right? That means we're looking within 2 standard deviations is where you will find the middle 95%. Okay, so 2 standard deviations. So 2 would be 75 and 59, right? Positive 2 is 2 above, negative 2 is 2 below. So they would be between 59 miles per hour and 75. Because again, 95% of the data, right here, 95% falls within 2 standard deviations. So within 2 standard deviations is a 95%. So 75 is 2 standard deviations above, 59 is 2 standard deviations below. Okay, moving on to the next problem. So complete the normal model. Again, normal model, you're thinking bell curve, and you're thinking, okay, 68%, 95%, 99.7. So, right, I can start filling out this bell curve right away. So 0 standard deviations to within 1 standard deviation, right, plus or minus 1 standard deviation, right, 68%. So 34, 34. Plus or minus 2 standard deviations, 95%. So again, this goes up by 27. So each one of these next 2 is 13.5. So that's 2 standard deviations. And then if you're within 3 standard deviations, that's 99.7% of the data. So that goes up by your 4.7. So this would be 2.35, 2.35. And what's left, because it should be 100%, is 0.3. So out here is 0.15, 0.15. If you're past 3 standard deviations, either above or below. So for our problem, the cost to eat dinner is, the average cost is 32, so that's your mu, and a standard deviation of $5.50. So the average cost is 32, so that goes right in the middle. So one standard deviation above that, 32, you would add 550, right? This is going to be one standard deviation. So you would add 550, so you would pay $37.50. If you were 2 standard deviations, I just add another 550. So this would be $43. And if you were 3, again, add another 550, $48.50. So how do I get those next numbers? I'm adding the standard deviation to each one of those each time, because that's the distance between the numbers, is the standard deviation. Okay, if you're 1 standard deviation below the mean, you would subtract 550. So 26.50, right? $26.50. Subtract another 550 to get 2 standard deviations below. So you're at $21. Subtract another 550 and you get $15.50 if you're 3 standard deviations below. So if I want to find the positive standard deviations, I want to be above the mean, I add 550. If I want to find how many standard deviations below, I'm subtracting 550. So we have it all filled out, so we should be able to answer this. So below 32, so 32, right, that would be all of these 4. But also 32 is right in the middle. So instead of adding up all 4 of those, we could just realize, oh, that's going to be 50%. Because 50% of the data is going to be less than 32. 52% is going to be, or 50% is going to be above 32. Right, between 32 and 48.5. So here's 32, here's 48.5. So that's going to be 34 plus 13.5% plus 2.35. Right? I'm adding up these 3 numbers because those are the 3 percentages between 32 and 48.50. Add those 3 up. Right? And you're going to get 49.85%. Now, some of you might be thinking, well, what if we just took 50% and subtracted 0.15? Could we do that? Well, yeah, because this entire top half is 50%. I'm cutting it off at 3 standard deviations, so I could have just subtracted 0.15, and yes, you would have gotten the same answer. Right? Either way works. You're going to see there's usually a couple different ways you can find these answers, by adding or subtracting, depending on what you see and what you understand the best. All right, so below 21, so here's 21 right here. So below would be these 2. So this would be 2.35 plus 0.15, right? That equals 2.5%. And then below 26.5, right? So here's 26.5. So below that, sorry, not below, above. So above 26.5, whoops. So above, right, that would be all of these 5 numbers. Or like we did before, I know from 32 on, that's 50% of the data. And then I can just add the 34%, and I get 84%. So instead of adding all 5 of those, right, I know half of the data, so this half here is 50% plus this 34%. That will give me my total that I'm looking for, so 84%. So anytime you hear empirical rule, when you hear the empirical rule, all they're talking about is this breakdown right here. Right? That's what they're talking about when you hear empirical rule. The the 68, 95, 99.7. Same idea when you hear normal distribution. You should be thinking this bell curve that's on your screen right now, right? Breaking it down into those percentages. It's just something you want to start to memorize, right? One standard deviation above or below, right? It's 68%. If you're within 2 standard deviations, that's 95%. If you're within 3, so that means up 3, positive 3, or below, minus 3, that's 99.7%. Again, those percentages is what you call the empirical rule. Again, normal distribution is what you kind of see a lot of in different parts of stats. So make sure you answer your essential question, right? Write your summary at the very end by answering that essential question, and you'll be done with your notes. Have a wonderful day.